sprint this morning, I want to teach you a strategy that's going to come in handy. So let's look at the first one. Now, today I'm going to write my thinking down on paper, just on this page, okay? When you get to the sprint, you don't have to write your thinking down on paper, but I want you to practice writing it with me just on this page. So here's what I'm going to think in my mind, and I'm going to write it. 2 times something equals 4. What is it? 2. So I'll put times 2 there and times 2 here. Okay? Then that tells me what's going in the box, which most of you probably already knew. Okay? So go ahead and write that now if you didn't get a chance to write it. So the next one, 2 times something equals 6. 3. So times 3 again. Pretty simple when it's a 1. 3 times something equals 6.
2.
Okay, what about the next one?
4.
3 times
2.
2.
Same answer.
So 2 times 2 is 4. Okay? Try these next 3 on your own using the same strategy. Just those 3. Okay, did you agree with me?
Yes.
All right. How are the ones at the bottom different?
Because it's
It's a
changes to the
denominator.
The denominator is missing, isn't it?
Yeah.
Okay, good. I like the way you tried to say that. Now, whenever it starts with a 1, you're just going to automatically know you multiply by whatever the numerator is, okay? So I'm going to multiply by 2. What do I get? 4. Okay? So, again, same thing. Multiply by 2. And then 2 times something equals 8.
4.
Okay? So 5 times 4.
20.
Good. Try those next 2 on your own. Okay, so fist to 5. You kind of know what you're doing? I know. I feel like you did this in 4th grade, okay? So now let's look at the sprint, just a second, okay? Let's look at the sprint, because some of those do look different than what we just did. So let's take a look at, let's start with like number 10 and just practice a few of these, okay? So everybody start with number 10. 4 times something equals 8. So 1 times 2, okay? Now you notice I don't have enough room to write times 2 in between the fractions, do I? So I'm just writing it to the side. That's only if you need to. You can just think it, okay? So the next one, 4 times 2 again. So 3 times 2 is?
6.
Okay. So 1 times what equals 3?
3.
3. So 4 times 3?
12.
Okay. The next one, 3 times something equals 9.
3.
Good. So 4 times 3?
12.
All right. So how's this one different? 14 is different. It's division. Okay. How do I know it's division? Because the first fraction has larger numbers than the second fraction. Okay. So in this case, I'll do 4 divided by something equals 2.
2.
So 2 divided by 2 is... So take a look at 15. I know it's division also because my 2 is larger than the 1. So 2 divided by something equals 1. What is it? 2 divided by 2 equals 1. So 6 divided by 2 equals 3. 2 divided by something equals 1. What is it?
2.
So 10 divided by 2 equals, is this one division? Yes.
Yes.
Is the next one?
Yes.
Yes. Looks to me like the rest of them are division on this column because I have a larger number on the right. My 10 is larger than 5. 10 is larger than 5. 9 is larger than 3. 12 is larger than 4. 3 is larger than 1. So that's how I know if I am dividing or not, okay? All right, so I'm going to give you 3 minutes. Okay, here are the answers for side A. 2, 10, 4, 6, 8, 6, 4, 9, 6, 2, 6, 12, 12, 1, 3, 5, 2, 4, 1, 2, 4, 3. Okay, 23. 4, 8, 2, 4, 15, 35, 4, 4, 42, 8, 9, 40, 54, 5, 56, 4, 7, 9, 72, 84, 5, 6. Okay, answers for side B. 10, 4, 6, 8, 6, 2, 6, 3, 9, 8, 8, 3, 9, 2, 1, 1, 5, 5, 3, 3, 3, 4. 12, 12, 3, 3, 25, 28, 3, 5, 35, 9, 8, 64, 45, 9, 48, 9, 1, 5, 12, 36, 4, 7. Okay, let's take a look at this. First thing I want to do is read it, then we're going to put a box around what we think is important. Mr. Hopkins has a 1-meter wire he is using to make clocks. Each 4th meter is marked off and divided into 5 smaller equal lengths. If Mr. Hopkins bends the wire at 3/4 meter, what fraction of the smaller marks is that?
Sounds like Miss Watkins.
Yeah?
Yeah.
It does a little bit. Okay, so here's what I want to talk about. We have a total, don't we?
Yes.
And we know what the denominator is.
Uh-huh.
Okay, so what can we draw? Okay, so let's draw a number line. Do I have my end marks? Do you know what they are? What are they?
0 and 1. 0 and 1.
0 and
Put
1.
2 lines in the middle.
Okay, now this says 4 is the denominator.
So you put 3 lines.
3 lines.
Or 2. Or 3.
I need 4 equal parts. Okay, and then I think, why don't we go ahead and label our fractions?
And
Okay, now just a minute. Bad 4. Okay, so the problem says each fourth meter is marked off and divided into 5 smaller equal lengths. So what do you think, Jesus?
You only have one. You only because you bend the wire 3 minutes.
You bend the wire at 3/4, so you think I need to mark that with a point?
Yeah.
I agree. Okay. But what about these 5 smaller equal lengths? I mean, what does that mean even? Lexi?
We draw 4 tick marks
But-
in between.
You got it. So 1/4 equals
Yeah, that's what I was thinking.
5 units. Okay? 1/4 equals 5 units. So Lexi said draw 4 tick marks between each. Okay? So now I'm going to keep going with that same idea. Looks a little bit like a ruler, doesn't it?
Yeah. Yeah.
Okay, so the question is asking what fraction of the smaller marks is 3/4 of a meter? Now we know that 3/4 would be 5 times 3, correct? So 3/4 would be 15, right? But the denominator cannot be 4. Why?
Because
There's 5 units, right?
because the numerator's too big.
Then, well, we can still have a numerator that's higher than a denominator, and it makes a whole number. But is 3/4 a whole number? No. So Lexi's right. You can't have a denominator larger, a numerator larger than the denominator unless it's a whole number. And we're still below the number 1. So what do you think the denominator is going to be?
50.
No, that's the numerator.
15.
Oh, 20.
Why do you say 20? Did you just get a good guess?
Yeah.
Okay, you guessed right. Why is 20 right?
Because you
multiply
15
4
times 5.
times
5. Because you won't multiply 5 times 4.
Because you'll multiply 5 times 4. But why do I need to put the 20 on there at all?
Because it's
It's a fraction.
To make a fraction, I need a denominator.
equal.
What does the denominator tell us, boys and girls? The number of equal parts. The number of equal parts. Do I have 20 equal parts?
Yes.
Yes, I do. So to figure out 3/4 of that, I know there's 15, 5, 10, 15, okay? That's how many parts would be shaded or whatever. But don't you have to mention the total number every single time, don't you?
Yes.
So 20 is your total. So Jair, you got it right even though you guessed.
Yeah.
Really good job, okay? All right, let's take a look at today's lesson. Before we do today's lesson, would you turn your paper over to the very back? And I want you to do this with me, okay? I want you to draw 4 rows of 3. Now, we're going to take a little walk down memory lane to 3rd grade.
Oh.
That's probably when you first started working with arrays, okay? Now, here's what I want you to do. I want you to think of all the addition and all the multiplication problems you could make to go along with this array. Okay? Go ahead and do that now on your paper. What do I have here? 4 groups of 3, or 4 copies of 3.
Yeah, that's right.
Okay, so what's 4 copies of 3?
12.
12. Okay, and if I turn this, what do I have?
4.
No, three copies of 4. Or 3 groups of 4, okay? All right, now if I take this first multiplication problem and I come up with 4 copies of 3, but I add,
It's not gonna work.
what does it look like?
Oh, that's repeated addition.
It's repeated addition. Did you forget about repeated addition?
Yeah.
Okay, so these two actually matched. And this one, when you do this repeated addition, it's going to be 3 copies of 4.
So
4 plus 4 plus 4 equals 12. Okay? Now, let's say I put that on a number line. Would I hop to 4 and then hop to 8 and then hop to 12? Yes, I would. Okay? So that's what we're doing today, but we're using fractions. Okay, I went ahead and wrote unit form down, and you don't have it. It's just a visual for you to see, okay? So I'm going to start with unit form. 1/3 plus 1/3 equals 2/3. Now, what does not change?
The
denominator.
The third does not change, so the denominator stays the same. So when you write 2/3, you're just adding the 2 top numbers, and you already know this, okay? How could I take this and make a multiplication problem out of it that's repeated, matches the repeated addition?
1 plus, no, 1/3 plus 1/3.
Honey, I said multiply.
Oh. 1/3.
How many copies of 1/3?
3 times 1, 1. 1/3 times 2.
Okay, 2 copies of 1/3 equals 2/3. Write that down. Okay, so looking at 2/3, that's my total. Do I need this to be more or less than 1 whole? Less. So 1 whole goes on the right, 0 on the left. How many tick marks do I need to show thirds? 2 tick marks. Go ahead and write your denominator down. Whoops. Okay, and here's what it looks like on a number line. 1/3 plus 1/3 equals 2/3. So you're going to circle your answer. Okay? Junior, how's your number line look today? Does it look great? Good. Okay? So that's pretty much what we're doing today. It's going to get a little harder because we're going to go above 1. But this is just setting the foundation for it. So starting with this, what's my answer?
3/4.
3/4. What does not change? The fourth, the denominator, okay? So how many copies of 1/4 do I have here?
3.
3 copies of 1/4 equals 3/4. Okay, so this number line is going to look a little different.
Give me 3.
Is 3/4 more or less than 1 whole?
Less.
Okay, so 1 goes on the right.
3 tick marks.
Okay, why 3 tick marks?
Because they're equal.
That shows 4 equal parts, okay? So now we have so 3 copies of 1/4. And circle 3/4. Okay, fist to 5 on this. Good, you ready? You want to close the door, please? Okay, So we're going to kick it up a notch and we're not going to write all those fractions. Because I don't want to write eighths. And it gets more and more and more, so pay attention to what I'm saying as we do this, okay? So first of all, I'm going to solve it with unit form. What's the answer?
7/8.
7/8. So the denominator is
8.
8. How could I use this repeated addition, 3/8 plus 3/8, and turn it into a multiplication problem?
Oh, 7 times 1/8.
Okay, so I said, I'm going to repeat the question. How could I use 3/8 plus 3/8 as a repeated addition, turn it into multiplication? How many copies do I have?
8 copies.
2.
2 copies
Of 3/8
of 3/8
equals 6. 6
plus, can't forget my 1/8,
plus 1/8.
equals
7.
7/8. So that's the multiplication. You can do repeated addition for part of it and then add out to the side. So 7/8, more or less than 1 whole? Less. What would 1 whole be? 8/8. Okay, so 7 tick marks. Now you know the easiest way to make eighths, don't you? Divide it in half. Then divide the halves in half. And then divide the fourths in half. And that gives you eighths. Okay, now I want to go ahead and just write this fraction right here. 0/8. So what am I adding together?
7/8.
No, I'm not. That's my answer.
3/8
3/8 plus 3/8 plus 1/8. So watch me. I'm going to count 1, 2, 3. Then 1, 2, 3. And how many more?
1.
1.
Oh, I get it.
So now, what's my answer?
7/8.
And I write that below and circle it. Okay? So is there a need to write all those fractions down? No, you can do it without. All right? If you get confused, am I going to say you can't? Of course not. If you get confused, write your fractions down. Let's look at the next problem. Now this one changes things. Because I've got 6 halves. Repeated addition is 2 halves plus 2 halves plus 2 halves. You can write it as a multiplication sentence, but when I solve this, it's going to be more than 1 whole.
Yeah, 16.
6 halves, remember this is a division problem. 6 divided by 2 equals,
3.
so my answer is 3. And this one would be 3 ones. Okay, so what is the far right number on my number line this time?
2.
3.
3.
Then you have 2.
So make sure you put your 1 and 2 on there. So those are your whole numbers. That has nothing to do with the denominator. What's the denominator?
2.
2. So you've got
2.
2 equal parts, which you already know how to mark half, don't you? Okay? So the repeated addition is what I'm putting on the number line. So I'm going to go 2 halves equals what?
1.
1 whole. So 2 halves plus what?
2.
2 halves plus 2 halves equals
3. No, 6.
6 halves or 3 ones. Okay? So did you write your 6 halves on there? Okay. So even though they gave us the answer, we still had to put it on the number line correctly. All right, so more than 1 I'm guessing is what we're doing now. How do I know that? It says mixed number. Okay? So let's start by figuring out the answer in unit form. 5/5 plus 3/5 equals 8/5. So let's write 8/5 here. Now, I don't think I can multiply anything together on this one, can I? Because I have nothing that's repeated. So all I have to figure out now is, how high does my number line need to go?
2.
To 2. Why do you say 2? You're right. How do you know it's not 3?
It's not above the whole number.
Cheney?
Oh, because it's bigger, like the 8 is larger than the 5, and it's like, it's 2.
Lexi?
If it would have, if the top number would be 10, then
You're right. The reason it's only 2 is because the numerator would be 10 on the whole number 2. Since we only have 8 as a numerator, we don't need to go past 2, do we? No. What if we had 12?
Then we would.
Then we'd have to go past 2, okay? So 10 divided by 5 equals 2. Good job, Lexi. So we have 0, 1, and 2. What's my denominator?
5.
5. So 4 tick marks between each whole number. Okay, so the first one is 5/5. Where do I stop?
At
number
1.
At 1 whole. 5/5 plus 3/5 equals 8/5. And how do I write that as a mixed number?
1 and 3.
1 3/5. Now, I want to remind you of that cool little trick for when you get confused on your mixed numbers, okay? So, since this 8/5 is really a division problem, correct? Okay, I can do 8 divided by 5. So go ahead and write that down. How many will be in each group? 1. When you subtract, remember you can take your numerator, put it on top of the divisor. Let me start over. Your remainder, put it on top of the divisor, and it gives you a fraction. Is that what George A. said it was? 1 3/5?
I don't know.
Yeah, because I wrote it down right here.
Oh, yeah.
So remember, you can use long division to figure out your mixed number. Let's look at the next one. 6/3 plus 1/3, 7/3.
2 thirds. It would be 2.
Whoops. Look what I did. So the 3 does not change, does it? Okay, so how can I make a multiplication problem out of this? I want to do that first.
Oh,
Now I know I'm going to put my 1/3 at the end, right?
7 times 1
No?
6. Oh, 6.
How can I break 6/3 apart into a repeated addition problem?
1 and the 1 plus 1 third plus
No, that's too many.
2
It's right.
2 times 1/3.
Well, that'd only be 2/3.
2 times.
You're on the right
3
track.
times 1/3.
2 times 3/3.
Woo.
Very good. Okay. So he could have done 6 times 1/3 and he would have got the same answer, right? But this will be easier to put on the number line. Oh, I was supposed to write multiplication here. Sorry. Do you have that on yours?
No, it's on numbers.
Okay.
Or that.
You don't have to rewrite it then. Okay, so now we have to figure out 7/3.
3.
How high do I need to go?
3. 2.
3
3.
2.
Okay, so Who said 3? You were right, okay? If you can't figure it out, what's a strategy you can use?
You can divide it.
You can divide it. So let's see if George is right. How many will be in each group? If I have 7, 3 groups, how many in each group?
2.
2. So 2 and
1/3.
1/3. Was George right when he said 3? Yeah. So 2 and 1/3, we already know the mixed number, don't we? Okay, so how do I make my number line here? Put your 1 and your 2. What's the denominator?
3.
3. So how many tick marks between each whole number? 2. Okay, so I'm going to do 2 copies of 3/3. So where's 3/3?
1.
1. And another copy of 3/3. Good. And 1/3. So is that 2 and 1/3?
Yes.
Okay, and your answer was 7/3.
Oh, yes, 1/3.
Okay, so is that the last problem?
Yes.
All right, good job.